Hi, everyone. Thank you for joining us today to learn more about GitOps for infrastructure and applications with Crossplane and Argo CD. This webinar was brought to you by Codefresh and Upbound. And just as a quick heads up, we are recording this webinar and we'll post it on our YouTube so you can watch it again at a later time if you'd like. If you have any questions throughout the webinar, please use the chat function or Q&A, and we'll have a dedicated Q&A portion at the very end. All that being said, let me take a moment to introduce our speakers today, Tracy and Viktor, before they kick this webinar off to you. Tracy, a Jackie of all trades and a mistress of being herself, is a developer evangelist at Codefresh, where she focuses on sharing her love for continuous delivery, the Argo project, and GitOps. Viktor is a developer evangelist at Upbound. His big passions are DevOps, containers, Kubernetes, microservices, continuous integration, delivery and development, and test-driven deployment. With that, I'll hand this over to Tracy and Viktor to kick this off.
I'll go first, Tracy.
Yeah, let me see if I can get us back going. All right, here we go. We're gonna try this again. Said I owed you. See if I remember everything. No, where'd my screen go? Okay, there we go. Hi, everybody. If this is your first exposure to me, I apologize in advance. But this is GitOps for infra and applications using Argo CD and Crossplane. We are Viktor and Tracy. Hello. And funnily enough, we're going straight into demo time, and that will let Viktor get some stuff set up, and then you get to hear me drawn on for about maybe 10 or 15 minutes, and then we'll get back to the juicy stuff.
Okay. I had no idea that's how it works. Let's go then. I had no idea. Okay, so I guess that if it's going to be half of the demo, if I understood right, then you need to tell me when to stop. Otherwise, I'm going to continue until the very end.
I think the idea was for you to let the cluster start getting going in the background. So I think
too late. I already created it.
Oh no, I didn't know that. You want me to go back and just do the slides instead then? And
yeah,
come back to the
do the slides. Do the slides.
All right, all right.
This is for everybody. You see how organized we are.
All right, let me see if I can. All right, unshare so I can go back to the slides. Participants, sure. This never happened. Oy.
That proves that this is not scripted. This is not a bot presenting. It's live humans over here.
All right, here's the droney part, but it's interesting to me. So a little bit of background on me really quick. I have been at Codefresh for all of a month. So we also have an additional panelist on here, Hannah, who is absolutely amazing to help me for those questions I can't ask you that I was probably going to pitch to Viktor anyway. So a lot of this was me learning while I was helping out with this. So what is GitOps? Open GitOps is a set of open source standards, basically where we tell you what you're supposed to be doing right and best practices and things that you should not be doing otherwise. But they're community focused, and it's about standardizing an approach to implementing GitOps. So Codefresh is one of the founding members. There are some other ones that are on the screen. So the main four GitOps principles are declarative. So you want a system managed by GitOps. 2, it needs to be version and immutable. So your desired state is stored somewhere in a way that enforces immutability, versioning, and your complete versioning history. It needs to be able to be pulled automatically. So your software agents should be able to go and do what they need to do without you having to do anything. And 4, continuously reconciled. So your software agents need to continuously observe your actual system state and attempt to apply the desired state. So what does that mean? How does GitOps for Kubernetes work? Well, the system is described in a declarative manner. So in practice, this means your Kubernetes manifests. The definition of the system is versioned and audited. In practice, this is typically Git for everyone. Choose your own provider on the other side. A software agent automatically pulls the Git state and matches the platform state. So in practice, this is either Argo CD or Flux. You're on with me today. So for today, it's Argo CD. And then 4, the state is continuously reconciled. So any changes happening should be reflected all the way around, and it should go the other way also. So Git to your cluster and your cluster back to Git should all look the same. And this is kind of that workflow that I just said in a very visual manner. Okay. Now, GitOps for Kubernetes using Argo CD. So basically, I love this thing. This is actually what made me apply for my position, to be completely honest. So here you see a hierarchical view of all of the Kubernetes resources that take part in your application. You see stuff like your synchronization details, your health, and basically green means good. So right now we have a healthy system. Everything related to our application is healthy and in sync. However, what if somebody decides to go back and start dabbling with some stuff that you didn't know that they were dabbling with? So if somebody initiates a change, well, that means things are out of sync. In the dashboard, that usually looks yellow. So if you look at the top right, we're out of sync. Somebody made a change, and that's not good. So Argo CD lets us know that that application is no longer in sync. It gives you a nice little app diff that I like, and that's the screenshot on the left. I usually use compact diff because lines, but as you can see in the screenshot, somebody added some extra ports that we didn't know about. So we want everything to go back in sync. If you look at the top right, well, the top left of the screenshot, you see that sync button? Click the sync button, and then things will get back okay. So Crossplane, which is fairly new to me, which is why we have Viktor. So there are 4 critical layers to well-built infrastructure. You got your foundational infrastructure, your platform, your shared services, and your application, and all of the layers build on top of each other. So like if you've got Terraform, then Kubernetes or Helm or whatever can build on top of that. Then we've got Argo and Vault and all that stuff, and you get how it goes. So let's get a little bit more specific. Right now, you probably use Argo CD for your applications, use Terraform or Pulumi for your infrastructure. In addition, you have Kubernetes manifests, but you also have HCL files or Go or TypeScript or however you want to build your applications. Now, I don't know about you, but I kind of really don't want to have to deal with all of that because that's too many files. So let's take it to the next level. And let me explain something before we take it to the next level. If you're working with Terraform, you already know why it's difficult to apply GitOps to the Terraform CLI. And if you've never seen any of Viktor's videos, he talks about that also. So go to his channel and look at that thing. Terraform has the first requirement, which is the declarative portion of it, but it doesn't satisfy the other 3. And so we're basically saying as soon as Terraform finishes this job, it doesn't really interface with the system in any way. So if you do something on one side that was created by Terraform, like manually delete a virtual machine, vanilla Terraform doesn't know about it. So basically Crossplane is the next level that kind of brings all of that together. Because now you can do Kubernetes manifest for apps and also do Kubernetes manifest for your infrastructure. What did I say wrong, Viktor? You look like you were going to tell me I did something wrong.
No, doing great.
All right, I shall continue. Crossplane. This is where Crossplane comes in. So they have similar capabilities to Terraform, so you can create your infrastructure, but the following major differences are Crossplane itself is a Kubernetes application. The infrastructure it creates can be pretty much anything. The Crossplane definitions are Kubernetes manifests, and you can either use manifests that describe the resources in the common cloud providers or create your own resources, which means you can pretty much write your own provider. And there's a blog post on Crossplane's website that goes into picking Crossplane over Terraform or using Crossplane with Terraform. That was a really, really good read. And I can add that into the chat later on. So let's talk about how Argo CD and Crossplane work together. Crossplane offers an easy way to model your infrastructure's Kubernetes manifest, which is great on its own, but if you put Argo CD into the mix, you essentially gain the advantages of GitOps for your infrastructure. So I'm letting you know now, I'm reading bullets, don't talk about me. All right, I didn't want to mess this one up. What this workflow shows is you know exactly what infrastructure you have simply by looking at the Git repository. You know exactly what was changing when and why and how by looking at the Git history. The infrastructure state is the same as the Git state. Terraform has its own state that is used as a single source of truth. You don't need any external credentials anymore. You can easily roll back to a previous version of your infra with a git reset or a git revert or however you like to do your aliases for your gits. And you completely avoid the whole configuration drift thing because Argo CD will instantly detect any manual changes as we saw in the screenshot earlier. So if you combine Argo CD and Crossplane, you have something that looks like this. It has all your infrastructure and your applications instead of just your applications, which I think is pretty darn cool, to be completely honest. But now that you saw that you can use Argo CD and Crossplane together for managing infrastructure, we can do the applications in the platform that they need the same way. So start from nothing, use Crossplane to create your Kubernetes cluster, commit the Crossplane manifest and manage it with Argo CD, use a standard manifest for your deployment, and then commit that manifest in Git also. And that workflow looks kind of like this. And you have a unified way to see all of it right here. And now it's time for the demo.
Yay! Okay. Demo. Okay, before the demo, very quick, few quick pointers or things on top of what you just heard from Tracy, just to be on the safe side, right? And that you're up to date with what I'm trying to say and what I'm trying to show and so on and so forth. So if you want to use GitOps to begin with, it needs to be Kubernetes. And the reason is very simple, not because Kubernetes is awesome, not because Kubernetes is better than anything else, which it is, but simply because all the tooling today that we have for GitOps is assuming that you're defining things in Kubernetes, right? Argo CD, Flux, Rancher Fleet, you name it, they're all assuming that you're managing stuff as Kubernetes resources. And I'm intentionally saying stuff because that doesn't have to be containers. And I think that that's one of the big misconceptions about Kubernetes. Kubernetes, we just started using Kubernetes with the goal of managing containers, but Kubernetes is really much more than that. It's about extensible API that rules the world and all that stuff, right? So now, if we want to apply GitOps outside of containers, let's say applications, that means that we need to extend Kubernetes API and bring additional custom resource definitions that will describe things other than containers, right? We already have those examples, like if you create an ingress in Kubernetes, it will do certain things, and among other things, it will create an external load balancer in your provider, right? So we already have those resources that interact and do stuff outside of managing containers. And what we're trying to do with Crossplane is to extend Kubernetes API to become a control plane through which you can manage everything. And everything can be AWS, Azure, on-prem something. I mean, theoretically, it doesn't matter, really. What does matter is that we can describe every single resource, no matter where that resource is, like AWS something, as a Kubernetes resource and manage it using all the tooling that we use in Kubernetes, including Argo CD and so on and so forth. Now, but that is still very complicated and complex. And the reason why I'm saying that is that I really, truly, believe a lot in shifting left. I think that if we just keep within our groups, then we don't get really far. And we cannot realistically expect that an average developer, let's say Node.js, something, will learn everything there is to learn about Kubernetes, about AWS, about this and that. That's unbearable. So what I'm going to try to show you is not only how we can use GitOps and Kubernetes to manage infrastructure and services, so on and so forth, but how we can shift left, how we can create completely new resources in Kubernetes that will be tailor-made for the rest of the people in our organization, right? And we call that compositions. So it needs to be the key goal here, apart from the typical, it needs to be stored in the declarative format in Git. You know, all the principles of GitOps that you heard at the beginning, I would add the fifth principle. I mean, it's not really GitOps principle, but fifth requirement, it needs to be simple. Just creating a cluster in AWS EKS cluster means that you need 1,000 lines of something to define it. It's complete madness, right? Kind of 7 VPCs and 8 subnets and auto-scaling groups and internet gateway. Nobody knows anymore what's going on, right? So simplicity, right? That's the keyword that you need to have in your mind while I'm showing whatever I'm going to show. And I'm going to share my screen right now, and we're going to go through the demo. So take a look at this definition. Let's say that now I'm a developer, right? I'm not SRE or DevOps or operator or whatever we are. And somebody created something completely new. That's not what I want to show you. Here is what I want to show. It says, Viktor, if you want to create and manage Kubernetes cluster yourself, you can use something called composite cluster. That something does not come out of the box. This is not Crossplane out of the box feature. This is simply an operator, an SRE in my company, creating and defining a completely new resource called composite cluster that will help everybody else to create and manage Kubernetes clusters, in this case in EKS, but in AWS, but it could be Google, it could be Azure, it could be whatever, right? And then it says, okay, first, when you define this, you need to specify which thing you want to reference. And I'm saying I want a cluster in AWS. If I change this to Google, I would get a cluster in Google. If I change this to Azure, I would get a cluster in Azure, right? This is custom made, right? Nothing out of the box. And that somebody said, you know what? You can specify actually some parameters. You don't need to think about subnets and VPCs and all those things, but I want to give you a certain level of freedom. And that level of freedom is to the level that you're comfortable with. So what are the things you're comfortable with? And then that person says, or everybody in the company says, hey, we would like to define the size of the nodes, and we would like to define what is the minimum number of nodes in a cluster. This assumes that the cluster will expand automatically, right, out to scale and what's not. And then you continue conversation and say, okay, so when you say that you want to specify the size of the nodes, do you really understand what are the sizes in AWS? And the answer could be yes, or the answer could be no. And if it's no, then we, during that design process, came to conclusion, okay, how about this? You can specify whether you want small servers or medium servers or large servers. And then I will figure out how to translate that to T3 something in AWS or whatever the exact sizes are. You don't need to worry about it. So at the end of the day, I got that new scheme, a new resource. I defined my manifest, and that manifest is this, right? It's like 10 lines of YAML, not even 10, something like that. And then we go to the second part where the requirement is, hey, I would like to have a production-ready cluster with Prometheus installed or whatever you use for monitoring. It should have security hardening and so on and so forth. And the answer is still this one, right? You don't need to worry about, that's all defined in composite cluster. But if you want to have that cluster be GitOps enabled or to have GitOps, you can define this second resource called GitOps. Again, completely custom, made for my company, where I'm saying, hey, you can reference some composition. And in this case, I'm saying I want to use GitOps based on Argo CD. It could be something else. Again, right? Complete freedom to design the solution and complete freedom to use the solution, to use the service. And here I'm specifying, okay, this is how you will find the information about that cluster that should be enabled, that should have GitOps there already operational, running. And the only thing that really matters is that you need to say, what is the repository that you want to use to store your manifests, right? To store your desired state. Excellent. Now, what I did is before this session started, as you heard at the very beginning, I wasn't really coordinated, paying attention. I already pushed this before this session to a Git repository. I did that in advance, right? And Argo CD figured out that I pushed something to a Git repository and did whatever it needs to do. And I'm going to show you what that whatever it needs to do is by showing you Argo CD, right? This is my Argo CD. Argo CD detected that I pushed that file. So I pushed only this. This is all I did, nothing else, right? I don't know, maybe 30 lines of YAML, not more. And as a result of that, Argo CD figured that out and figured out that in that repository, there are two things that matter in this context. Composite cluster, that's that first 10 lines of YAML. And where is the other one? I'll find it. Yeah. And here it is, the GitOps one, right? I don't know whether you can see it. If not, let me know in the comments. But basically detected those two definitions and created it. Now, what happened is that that's a user-facing custom resource. Out of this one, all those were created, right? Because those are all the details that ops people, SREs, whomever, care about, but you as a user, you don't, right? So you specify that YAML, and Crossplane figured out that what you really, really want when you said, I want a cluster with small nodes, that you want an internet gateway, route table, security group, subnet, VPC, node group, where is it? Releases. You want that cluster to already have some tools installed there, and I will show you those tools later. Actually, you can see for the names that cluster, newly created cluster, should have Crossplane installed and Prometheus and some roles and policy attachments and madness, right? What we need to do with AWS is complicated, complex, right? And we are trying to hide that complexity, not by creating an opinionated solution, but by giving tools to SREs in a company to create services for everybody else. And the same thing goes for GitOps, which figured out where the new cluster is, how it was created, how to connect to it. And once that cluster was up and running, it installed whatever needs to be installed in that cluster to make sure that Argo CD is running, that the project is created, that there is the root application or app of apps in that newly created cluster, that it is configured with a Git repository that was specified in that YAML, and so on and so forth, right? So all those things happen. I committed those things in advance, and it took like maybe 20 minutes until AWS created everything and so on and so forth. So now I'm kind of jumping forward in time, and everything is up and running. I was just too scared of a possible mistake to do it live, but you need to trust me that I did it. Now, apart from Argo CD doing whatever it needs to do to reconcile Git with a Kubernetes cluster, the management cluster, and then Crossplane taking taking those two compositions, expanding them in everything that is needed, and creating all the resources in AWS, and applying all the manifests in that newly created cluster, and so on and so forth. As a result, we can also see what's going on by querying that management cluster. We can say kubectl get managed, which is a shortcut in Crossplane that says all the resources managed by Crossplane itself. And you can see now that all the stuff that was happening is defined and is running and is managed by a Kubernetes cluster, which in this case is extended by Crossplane. You can see all those same resources, like there is internet gateway, VPC, and route table, and so on and so forth. Everything needed, and not only on infrastructure or AWS layer, but also some Helm charts were applied in that newly created cluster. Some Kubernetes resources were created, and so on and so forth. Now, that's from the end user perspective, from a perspective of somebody to whom you shifted or enabled to manage clusters themselves and get production ready clusters, and so on and so forth. Now, the way how that happened, and I said that this is unopinionated, this is not coming out of the box in Crossplane. This is, think of it as a tool that enables SREs to create services. And the way how all that happened, how an SRE could have defined that is based on this. There are two important types of files. One is a definition, right? Now, imagine that we go at the very beginning of the process, and somebody creates a new composite resource definition, which gets converted by Crossplane into custom resource definitions in Kubernetes, and says, I'm going to call this something composite cluster. That's the same name that I used in that YAML, end user YAML. And I'm going to use OpenAPI schema to define some properties, to define parameters. And those parameters will be version, node size, and minimum node count. The same ones that I used in that YAML at the very beginning, right? I'm defining what will be the future interface that others will be able to use to consume my services as SRE or DevOps or whatever we are called today. And then once I create this, I can have as many implementations of that interface as I want. So I can have, for example, for AWS implementation of that, that is here, KTS, EKS, and here, right? This is one implementation of that schema, of that custom resource definition. We call it compositions in Crossplane. And this defines all the stuff that you need, but not necessarily want to expose to everybody else. Hey, when somebody says that they want that and they choose AWS, because I would have not exactly, I would have equivalent of this file in Google or Azure or whatever. But in case of AWS, I should create something called cluster. There are some properties for that. This is EKS cluster. And I'm going to create later on some node group for that cluster. And I will have some additional properties here. This is basically similar to what you would be doing with Terraform or Pulumi. You need to define all the resources you want to manage with all the parameters. And then we have some patches. Like here I'm saying, this is a good example. Here I'm saying, whenever somebody says that they want node size to be small, medium, or large, I'm going to translate that to something that AWS understands. So whenever somebody says small, I'm going to actually tell AWS he doesn't know what he's doing. He really, really, really wants to say T3 small or whatever, right? And so on and so forth. I'm defining here all the AWS resources like roles, another role, more roles, role policy attachments, more attachments, stuff, right? A lot of things that we need to do, but we do not, but are so complex that we cannot enable others to do the same. We need to simplify things. And that's actually the whole idea behind all this. Subnets and so on and so forth. Route table, there's a lot of things. And then I'm saying, hey, you know what? I want to also define something called provider config. So when a Kubernetes cluster is created, I want to dynamically configure Helm in this case to do something in that cluster. And then, and I'm doing all that through Kubernetes secrets. That's all happening in the background. And when Kubernetes cluster is created, I'm going to install Crossplane in that cluster, that new cluster, by applying this Helm chart. And I'm going to install, what am I doing here? Prometheus, right? And then I'm going to use Kubernetes provider. There are many providers that we have. And then I'm going to create a namespace in that cluster somewhere here. Here we are, production namespace. I'm going to create other things. I'm not only going to create all the AWS resources required for us to run cluster, but also make that cluster production ready with whichever tools are required, but not necessarily in control of everybody else in the company. So I defined all that. And then as a user, I do not need to worry about all that. I just say, hey, what I showed you already earlier, all you have to do, no, that's not the one I wanted to do. All you have to do is define something like this, right? The result of those hundreds and hundreds and hundreds of lines of YAML is that I, as end user, can create 10 lines of YAML and say, I just want a cluster. And I want them to be small nodes because I'm cheap, right? Or whatever you want. And I want to enable it to be GitOps ready. And all I have to do is really specify the repository that should be used. Now, I could show you the definitions of how I created composition for the second part for GitOps, but it follows the same logic more or less. So I will skip that for now. Now, let's give this new cluster to a test, right? Let's double check whether everything works, whether Crossplane really created cluster, installed everything it needs to install, and most importantly for this conversation, whether it is GitOps ready, right? Whether it is already has Argo CD installed, configured, and all the jazz, right? So what I'm going to do is that I'm going to get a Kubernetes secret from the management cluster that Crossplane created that contains all the configuration, kubeconfig essentially, that I can fetch to connect to that newly created cluster. So I'm now switching from the management cluster to that cluster that I created before I started this session. And I can show you and prove that it works to begin with by saying kubectl kubeconfig is this one that I just downloaded. And let's retrieve all the namespaces. Here we are. Come on, come on, come on. There we are, right? This is the newly created cluster that already has, you can see it by namespaces, already has Argo CD up and running, Crossplane up and running. It has an empty namespace. This is important because I'm getting to it in a second. An empty namespace for me to deploy my applications. Let's say that this is production. and it has Prometheus for monitoring. It could be anything else. You're in control. You define what the composition is. What I'm going to do now is that I'm going to create a tunnel to the Argo CD, not the one I showed you, not the one that has a lot of things, but the Argo CD that is installed in that newly created cluster. And I'm going to open it in browser. If I find where my browser is. So this is the management Argo CD. I'm going to open a local host 8080, right? Let me make this bigger. If I manage to figure out how to do that, why Control plus, Command plus doesn't work. I cannot make it bigger. This is horrible. I need zoom in. Okay, zoom in. This is so shameful that I don't know which keyboard shortcut is zoom in. Anyway, admin 123. That's the most secure password you can have. And here, this is Argo CD already configured for the newly created cluster for you to manage applications. And you can see here there is nothing, right? Nothing is running. There is only the placeholder application. Nothing is there yet. So I'm going to change that right now, right? And keep in mind that I still want to keep everything very simple as possible, right? And as simple as possible can mean that I'm going to create a new directory in this repository. I'm now in a local copy of my Git repo. And I'm going to show you one example that I have, right? Here it is, there. And I'm saying here, hey, how about I leverage the same advantages of simplification from before? And I have, and this Kubernetes, newly created Kubernetes cluster is already configured to have a few additional, one actually additional crossplane definition that is called up. And you can choose, do you want the front-end application, back-end application with the database? You don't need to worry about creating stateful sets and deployments and ingresses and services and virtual services and whether it's ingress or linkerd, you know, and then you open a window and jump because that's how complicated things are. I'm going to simplify it one more time and say you can create something called app application. You can choose whether it's this front-end or something else. That's all specified in auto-generated documentation. You want to deploy something to production. You want the image to be this one, and you want this to be the host, the address through which your front-end application should be deployed. Say, excellent, this is simple. You don't need to worry about too many things. All you have to do is to define it, write it, which I'm not doing right now. And I'm going to copy now this to the directory app because that's the directory apps actually. That's the directory that is pre-configured in that newly created cluster in that repository, right? So I'm copying it there. I'm not going to interact with my Kubernetes cluster in any formal way. So I'm not touching it, right? All I'm doing is defining simple manifests and pushing them about to push them to Git. But before I do, let me show you one more and say, oh, this is not enough for you. You would like to create one more application. In this case, it will be almost the same, still application. I'm just specifying a different type of application, different reference. This should be backend application, whatever backend means, right? Maybe stateful set, maybe whichever storage somebody else defined in advance. Same thing like before. I wanted to run in production namespace. This is the image. And I'm going to expose port. The port is not the default port 80, it will be 8080, right? Very simple. And then I just do the same thing as before. I copy the file, which I forgot, app backend, I think it's called. There we are, to the apps directory. And then all I have to do is add things and commit things. I am not inspired, so I don't know what to write here. You should always write serious messages that explain people what you're committing. And I'm going to push this to Git, right? So my only interaction, the only point of contact that I have as a developer is simple manifests that are well documented, you know, that they have their API schema, all that stuff. Essentially, they're Kubernetes resources, but you don't need to worry about that. I'm pushing that to Git. And then Argo CD, already pre-configured in that newly created cluster that created before, also by pushing it to Git, should kick in and do the job. And we can see whether that's true. Look at this. This is the one that was empty a minute ago. And now it created one application and another application. One is called Devil's Toolkit. The other one is called Silly Demo. And that gets converted into whatever the designer of that composition thought is important. There are some Kubernetes objects over here and so on and so forth. And let's see whether all this worked by querying that. I said that I'm not going to go to the newly created cluster ever, but I'm going to break that rule once just to show you that things are really happening over there. kubectl --kube config, the one that I generated a second ago, and namespace is production, get all and ingresses. And there we go, right?
Nice.
This was generated there. Crossplane understood that when you say app application, that you want really this and this and that. How did it understand? Because somebody designed that composition, and we got 2 pods of one application, another pod another. We have 2 services, one for each application, 2 deployments. Deployments created replica set. One of them has horizontal pod autoscaler. That's why we have 2 pods over here, and one has ingress, which is pointing to certain address. And that's the quick demo. There is actually, and then we lived happily ever after. Isn't that how you should finish the story always?
I feel like it, but we're also using AWS, so that's up for debate. I have some questions I think that will be better answered while you still have the demo up, and then the rest I can keep for after the slides. Okay, sure. So one of the questions was, so whenever you were running kubectl Git managed resources, there was a question as to why the service group was on ready false status, even if during the description that the resource sync was good. So it was showing false
one of
status
them
while the sync
was
good.
ready false, but I did not have enough time in between setting up the demo and starting this webinar to check why that is. And I tried to trick everybody, thought that you will not notice, so that it turns out that I'm a demo god that never makes a mistake, but you caught me. I'm ashamed.
We've got some sharpshooters here in the chat, and of course my earpod. Where's my headphone? Okay, here we go. All right, sorry about that. Okay, so there's the answer to that one. The other question was, and we do have some answers in chat, but not everybody, some people might be phoning it in. So another question was, how would you authenticate with the cloud provider's APIs to create the clusters?
So that's also one of the differences. Since we are Crossplane in Kubernetes needs to know how to authenticate with API of a provider, right? So before I started this webinar, while I was setting up the demo, when I installed Crossplane in a management cluster, I created a secret with authentication to AWS, right? But that's for Crossplane. You as a user, and this is different from many other tools, you as a user, you do not need to have or know the authentication to any of those providers. Your access is controlled through the access of Kubernetes itself, right? So Crossplane has access to AWS in this case, and you have access to Crossplane. And the administrator of that cluster could have said, hey, you know what? You have only access to this namespace, and that namespace allows you to claim those types of resources or those compositions and not some others because I don't trust you or whatever, right? But access control is based on access control of Kubernetes, and Crossplane needs to know how to communicate with some API. Or since we are using Argo CD, then actually you do not even need to give access to Kubernetes management Kubernetes cluster to anybody. You can say just that's the Git repository, and whomever has access to that Git repository can do those things. And maybe nobody has access. Maybe people can just create a pull request and then you review it and merge it and stuff like that, right? So it really depends whether you want access to be on a Git level or on a Kubernetes level or both of those, but not really on AWS level.
Thanks. All right, I'm gonna jump to the rest of the slides and then we'll have the rest of Q&A after. So I haven't forgotten the rest of the questions that are in the chat.
Yes.
Awesome. All right, let's see if I can find out where it went. Oh, there it is. All right. That was a very awesome demo. I will be playing with Crossplane as soon as I get up. Well, as soon as we're through with launch, I'm just saying. So Crossplane plus Argo CD. When I say we only had a few slides left, I'm already at the recap. So GitOps everywhere. Use Argo CD for your applications. Use Crossplane for your infrastructure. Argo CD and Crossplane work great together, as you just saw in that awesome superhuman demo that Victor just did. Change infra or apps with just a git commit. And it's a common language for developers and operators without having to deal with all the manifests, HCL, Python, TypeScript, and stuff, and JSON. So if you want to learn more about the enterprise version of Crossplane, that would be Upbound, which is where Victor is. That's the link for that. And if you want to know more about enterprise Argo, which is at Codefresh, which is where I am at, you can use that link for sign up. And I think that is my last slide. So I will leave that up for just a second so you all can obtain those links. And I will go back to the questions because we had some really good questions in here. Let's see here. All right. So a question someone had towards the beginning was, where did it go? All right, it's a bit of a chicken and egg situation with Crossplane. I need to be able to provision a cluster to begin with.
Yes, absolutely. You need a Kubernetes cluster to run Crossplane, but that Kubernetes cluster, it's a similar situation like with Argo CD. You need Argo CD running before you can actually start using Argo CD, right? And it needs to run in Kubernetes. Same thing with Crossplane. And similarly to Argo CD, once it's running somewhere, it can manage itself. So what I would typically do as a first step is actually what I'm doing right now in this webinar. I'm running my management cluster in Rancher, right? Okay. Rancher desktop, sorry, Rancher desktop, local, not Rancher desktop. And I could use that to create a real cluster as I did. And now I could actually transfer in that real cluster Crossplane and say, hey, use the same manifest that I used in Rancher desktop from that new cluster and manage yourself, right? So you do need to have that extra step, additional step at the very beginning. But once you create the first real cluster and you install Crossplane over there, you can say, hey, now you manage yourself. Here are the manifests. This is how I created you. I had to do the initial push to create you, but now you're managing yourself.
All right, which also I think kind of partners with another question, which was, can we use GitOps/Argo CD to configure Argo CD itself? I don't know if you or Hannah wants to answer that one.
Yeah, I can answer. I mean, yes, this once you install Argo CD, which you need to do with kubectl something or Helm, then you can say, hey, the manifest that I used and executed to kubectl, if I push them to Git, and if I tell that newly created Argo CD, that's where the manifests are, then Argo CD will synchronize those manifests. If they happen to describe Argo CD itself, that's fine by Argo CD.
All right.
I don't know whether that's what, Hannah, I think that I interrupted you. You want to answer, so.
Oh, no, I wasn't prepared. I was like, oh, wait, I'm muted. No, but I agree.
All right, let's see. Oh yeah, how is Crossplane different from Terraform? Like, is it a way to get this? I like this analogy. Is it a way to getting a single pane of glass to manage infra and applications with the help of Argo CD and Crossplane? So like, how is it just different than just we're doing Terraform?
So there are some obvious differences, like, hey, Crossplane uses YAML and Terraform uses HCL, but those are trivial differences that don't really matter. What does matter is that Crossplane extends Kubernetes API with all the benefits that we are used to when working with applications typically, right? That means that whatever is in your head that you're saying, hey, I'm using Kubernetes because of this and that for my applications, same reasoning applies to Crossplane. Like drift detection, right? If I just execute tool X, something, and then I get my infrastructure, after that, nothing will happen. If I destroy intentionally or randomly or by accident, something happens to a node group, there is nothing to correct that until the next time I execute again something, right? Now, Crossplane uses the same logic like logic in Kubernetes. Like if a pod goes down, it will be recreated by Kubernetes, right? Assuming that it is part of a deployment or stateful set or something. Same thing with Crossplane. Crossplane is continuously monitoring all the real resources like AWS, Azure, this or that. And whenever there is a drift between what is defined in Kubernetes and what is the real deal, it will correct it. So think of Argo CD taking care of drifts and synchronizations continuously between Git and Kubernetes, and then Crossplane taking care of whatever is in Kubernetes and then onward, right, in your AWS. So if you think of it as three parts, Git, Kubernetes, something real, AWS, then Argo CD takes care of the first part, Crossplane takes care of the second part. And then there is compositions. There's another huge difference that you can create compositions like what I did here, create completely new custom resources made for you, for your organization, which Crossplane converts into Kubernetes resource definitions and Kubernetes resources so that you can do like things that I did before. Like, hey, I want to create composite cluster or APP or GitOps, right? Those things do not exist, but Crossplane gives you means to create your own resources that do whatever you want them to do.
Nice. All right, let's see. I think I got like 4 more. Wait, did I already ask about the APIs? I can't remember anymore. Did I ask about the APIs? I didn't.
Ask again,
okay.
and then we'll answer and say, what are you doing, Tracy?
All right, I forgot to copy it to my question sheet. So there were a couple of answers for this one in the chat. But how would you authenticate with the cloud provider's API to create the clusters?
Yeah. So, yeah. What are you doing, Tracy?
Yeah, we
That's
answered
what I
that.
thought. Okay,
Yeah, we got that.
Exactly.
with the exact same intro, if I'm not mistaken. Okay.
I was waiting for you to sleep up.
Hey, let's see. This one also has an answer, but can we deal with bare metal or kube admin style provision K8s clusters? That was the question.
Depends. So I don't know whether, for example, whether there is a specific provider already created, right? So think of it similar way as Terraform modules, right? There is Crossplane, and then there are providers that do something. I know only of a fraction of the providers because simply I'm not using absolutely everything that exists. So I don't know whether today Crossplane has a provider for bare metal something, right? Mm-hmm. But as long as there is an API at the other end that Crossplane can communicate with, then it's only a question either picking a provider that somebody else created or you creating a provider yourself. There are 2 ways you can do that. You can write Go code. Don't get scared. Go is cool. Or if there is already a Terraform module for that something, it's a relatively easy process to convert Terraform module into Crossplane provider, and then that would kickstart you faster.
All right, chat people, I haven't forgotten about you. I'm going to the Q&A section. All right, let's see. When it comes to managing the lifecycle of Kubernetes clusters, what is your take on the tool to use? Would you recommend Crossplane over Cluster API?
Yes.
I like those definitive answers.
No, Cluster API is great, but first of all, Cluster API is less mature, more green than Crossplane, which is trendy to say because Crossplane is also does not exist for 50 years. But so you can do the same things that you're doing, give or take conceptually. It's not the same syntax, same commands, but same things you can do with Crossplane. The major difference is that Cluster API is focused only and exclusively on Kubernetes, and giving you very slow, not a lot of control what's happening with dependent resources, and it's definitely not going outside Kubernetes, because it's never only Kubernetes. The devs in my organization might need the Kubernetes cluster to deploy their applications connected to an RDS instance in AWS, right, for the database. So I believe that we need more than Kubernetes. I think that Cluster API is in a closer to being a category like EKS Cattle, right? Which kind of, hey, you can create a Kubernetes cluster in AWS, and that's about it, right? The scope of Crossplane is much bigger than that.
Okay. What do you think about, is it Civo, C-I-V-O, Civo, as managed cluster?
Civo.
Is it okay? It is really cheap, and community already has a provider for it. So what do you think about it?
Yeah, first of all, big thanks to Anais. I think that we all know her. She created a provider for Crossplane for Civo, and I think that Civo is great. I wouldn't put it. I would not compare Civo and, let's say, GKE or EKS. I think that they're different categories. Big providers and small providers. But if you want to go for something extremely fast, like it creates cluster in 90 seconds. I mean, that's insane. Extremely lightweight and extremely cheap, but good. Not only kind of cheap like IKEA cheap, but cheap but good. Civo is amazing. It's my favorite cloud provider for Kubernetes among the smaller ones, let's say.
All right, I think I have one more in my queue.
I tend to answer all the questions. I don't know if any of you wants to answer anything, just jump in.
I'm enjoying it. No, you're not. I'm enjoying it. I think I have one more in the Q&A and two more in chat. If you remove a cluster definition from your YAML, will Crossplane outright delete the cluster with all backing storage, load balancers, etc.?
Yes, unless you tell it not to do that. So you can configure a resource and say, do not delete orphan resources, for example, right? And things like that. But by default, if you don't say anything, yes, if I would delete now any of those Kubernetes resources, then the equivalent resource, in this case in AWS, would be deleted. You can say that you don't want to do that, though.
Okay. Let's see. For Argo and Crossplane, is it advisable to use EKS with Fargate? Ooh, Fargate compute? They don't need any privilege permissions?
Is it advisable to use Fargate? Better somebody else answers, because if I start talking about Fargate, that's not going to end up well.
I don't know too much about Fargate. Yeah.
Only Fargate I like is like a combination of Farscape and Stargate. So I got nothing over on this side either. All right, I'll copy yours, Brendan. I'll copy your questions somewhere. All right. How well does Crossplane handle the AWS resources that take a long time to create a provision, such as RDS or EKS clusters? Does it report the resource to be healthy only after they've been fully deployed?
Yes, so it has different statuses, like not synchronized, synchronized, provisioning, ready. Ready is when it's ready, right? Whenever, now ready depends from resource to resource, and whomever worked directly with AWS knows that their API is just all over the place. But yes, it reports different statuses, and it's ready when it's fully operational. At least that's intention. And then you have a combination of different resources. So if one resource needs something, a good example would be Helm chart that I used before, that should be applied to the newly created cluster, but cluster does not exist initially. So Crossplane tries to balance those dependencies. So I cannot do anything with you because you require something from something else. I'll try later, 10 seconds later, and see whether, oh, is the database now up and running? Yes. Okay, that means that now I can create, let's say, actually, if database server up and running? Yes, that means that then I can do this thing that will create a database in that server, and then I can do this thing to create a user in that server. So it watches for statuses, so which enable certain resources to do certain things.
And I'm going to end our question Q&A. This is actually going to take us on out with a cheeky question, but I like it. When should I not use Crossplane?
When I say Kubernetes and you say,
There's your answer, Brendan. That was awesome. Well, for anyone that's still around, I did add the links for signing up for the enterprise versions trial, whatever, in the chat. So you may need to scroll up. Yeah, he did mic drop, didn't he?
He did.
And does anybody have anything else? I enjoyed
We can
this. This
ping
was
any
very
of us,
informative.
I'm guessing. I'm now speaking in other people's names. For me, for sure, I'm guessing for everybody, just
Yeah.
ping us with questions or requests or anything. You know, Slack is everywhere. CNCF probably, Kubernetes, Slack.
We're all there.
We're all in CNCF
Yeah,
Slack, so
I think we're all in the CNCF Slack, so
yeah,
definitely.
So just ping us over there.
Yeah.
All right, and then I think this recording will be up within the next few days on our YouTube channel. And as always, just because I absolutely adore Victor, even though we only just really met yesterday, his videos are awesome. So please go see those. Okay, Amber. All right. Thanks, everybody.
Cheers.